the xParticles constraints will add a spring between each particle. Let's have a look at how this looks within the scene. What we're going to do is we're going to get a disk and then change this disk segments from 2 and rotation segments to 6. And what we want to do is emit one particle per point. Get an xParticles emitter. In the objects tag, we're going to change the emitter shape to object. Drop the disk into the objects field and change the emit from polygon center to points. The emission to speed of 0. We also need to enable one particle per source element and make sure it's in shot mode so it only emits for one frame. I'm going to change our display from dots to circles filled and our size to 5. So now if I go up one frame, we'll get our particles emitted on these points. We can hide the disk. What we want to do is put a constraint between each of these particles. So if we enable constraints, make sure it's set to draw them in the viewport with the display and the emitter. Go back to the constraints. We're going to first use connect at birth and change the radius to be higher than 40 centimeters, which is the default, because the radius here is greater than that. Let's set it to something like 80. Go up one frame, and here you can see displayed the actual constraints. And what that's doing is creating this spring between each particle, and that's going to keep the particles together with various options on stiffness, the radius, and the breaking. We can add more in by enabling either higher constraints, radius, or connection limits. Let's put this to 12, this to 200. Go back and up one frame. And you can see we've got more constraints added into the system, and each particle is further tied to each other. You can also now add in modifiers such as turbulence. Push play, and you'll see how they're held together with the springs. The constraints can be used for any effects such as viscosity by enabling the viscosity mode, friction, surface tension, and collisions. These can be good for fluid systems, making sand, and doing many other effects. One thing to note with the constraints and other dynamic objects in Cinema 4D and xParticles is you need to work with the settings that you'll find in your project settings window, which is Command D on a Mac or Control D on a PC. We have a new tab called xParticles. Within here you can change the subframe steps, collisions, iterations, and accuracy. All of these settings add memory overhead, but also give you more correct simulations. Let's have a look at setting up a viscosity fluid. Create a new scene. We're going to get a disk as a collider floor, a sphere as a collision object. Select both of them, add a collider tag from the xParticles tags menu, and turn the bounce down and the friction up. We need an emitter, so go to your xParticles menu, add an emitter. We're going to set this to spherical mode and our direction to be -y. We're going to get the display from dots to squares, gradient parameter, and we're going to set that to speed. We also need gravity within our scene, so go to modifiers, motion, gravity, and now our particles will fall down and hit the floor. let's add an SPH fluid object. So now we have a fluid simulation. We can change the settings on this slightly. Let's get a higher density so that the particles stay more close to each other. And we also need more particles. Let's go to the emissions tab and set this to 2000. So we have the fluid sim working, but we need these to be viscous. Add in the constraints, enable viscosity, push play, see how we're looking by default. You can see they're now a lot more together and a lot slower. We can change the connection limit, the radius, and the stiffness of the particles. As you can see, it's even more viscous. The higher the settings, the more viscous you'll get. The stiffness has a drop down arrow. If we open that, you'll see the stiffness settings can be mapped to a parameter such as temperature, mass, age, or speed. That means that the stiffness will happen over the time of the spline based on the parameter you set. All of these connections and constraints have this option, such as friction, surface tension, and connections.